Hello guys, my name is Sri Vallabh. I will be basically covering about hard disk in this video. I will be teaching you how the hard disk looks, how it exactly is built and how it exactly operates. So let us back up a little bit, way back in 19th century where people were using gramophones. So our currently used hard disk is exactly based on the concept of gramophones. You will have a read and write head and you will have a disk rotating, and the read and write head takes the information from the disk and you get the output. The same concept. So the current hard disk is actually, let me tell you the ingredients of the hard disk. One ingredient is the platters. The second one is the actuator. The third one is the actuator arm. So coming to platters. Platters are basically magnetic disks, highly magnetized disks, which are made up of quartz or highly mirrorized glass. So the memory imprint on the hard disk takes place through magnetic induction, on the principle of magnetic induction. So as I told you, there is something called as actuator. Actuator, the CPU sends the data to fetch the data from the hard disk. Says, dude, I want to get a file called filestructures.pdf. Get me this. So the actuator moves the read and write arm to the specified platter or the specified place and gets the disk. Before understanding complex access of memory, let us see what exactly the platter contains. The platter is divided into tracks. Tracks, in the case, you can just imagine the Olympic tracks. In case of Olympics, the tracks is actually ellipse in shape, but here it is circular in shape. Maybe you can have a hard look at the diagram over here. It is divided into multiple tracks. The standard number of tracks per disk is 63 tracks. And further, the tracks are divided into something called as sectors. Sectors again is the same as the mathematical sector that we know. The radii cuts an arc. That is a sector. So, as we know, the track divides the sector, actually divides each and every track into various other pieces. Each and every sector contains 512 bytes. It can take up to 512 bytes. And coming to platters, we are not exactly talking about a single platter in the hard disk. There are multiple platters. For example, if there are 3 platters in the hard disk, we will have 6 faces, 6 read and write faces actually. So actually later in this video I will be showing you a 3D graphic animation of how exactly the hard disk works. So maybe you could understand more about the hard disk. Thank you.
Well, hello again guys. This was the 3D graphics that I was talking about the hard disk. Well, let me explain it to you. This is the actuator arm and this is the read-write head which is going to get the data for you, and this is the platter. This is the platter. Basically in a SATA hard disk there will be 3 platters with 6 read-write heads, but here I've just made 2 platters with 4 read-write heads. You can see the 4 read-write heads over here, 1 2 3 4. So these read-write heads actually move in a very specified angle from here to here, maybe that is it, but the platters rotate at the speed of 5400 rpm to 7200 rpm. So the read-write head has been restricted to move only in a specified arc location. That is it. So maybe I could show you how the tracks and sectors are divided. Just hold on. Yeah, this is how the tracks are created. From the center there are equally consequential circles, that is concentric circles, coming up from the center of the circle, and then there are sectors that are dividing each and every concentric circle to form a sector. Each and every sector over here, each and every sector contains 512 bytes of data. That is, this area contains 512 bytes of data. One more thing that you need to know is the time taken to extract the data from the hard disk and give it back to the user. During that process, you need to take care of a various delay time. One is the seek time. Seek time is actually the time taken by the read-write disk, the time taken by the read-write disk to move to the particular disk. Read-write head, sorry, the time taken by the read-write head to move to the particular disk in order to get the data. The time that is called as seek time. Second thing is rotational delay. Rotational delay is the delay obtained or the time taken by the disk to rotate to the information where to rotate to the position where the information is present. That is the rotational delay. Third one is transfer rate. Transfer rate is the rate at which the data is transferred from the disk to the read-write head and then to the CPU. That is basically the transfer rate. So maybe I have told everything about how data is stored. The only thing left is how to access the data. I mean, there's one more thing I need to tell you. See, as we know, as actually everyone knows, the best way to store anything is in an order. So you might expect to store data in consecutive sectors. You can actually do it. You can store a few data here, you can store A, B, C, D, E, F, G over here, then H, I, J, K, L, M, N, O, P over here, and then as it goes on in consecutive sectors. But the disadvantage in this is the read-write head would have been reading the data over here. By the time it transfers its data from this sector to the read-write head, the disk would have been moved by a certain distance. As you know, the speed is very high. As the speed is very high, it would have been moved to a very random spot. And henceforth, if you have to get back to the address, you would have to complete one complete rotation to come to the next address. So that is actually a problem rather than an advantage. So what we do is, what the principle applied here, it's called as interleaving method. Interleaving method is depending upon the speed of the hard disk. We try to predict the next address of the hard disk. After reading 512 bytes of data in a sector, we try to predict the next sector. So in this way, if this was sector 1, I'm sorry I have not named it, I'm really very new to graphics, so this is all I could do. I will try my level best in the next video. If this was called 1, we could predict, well, this could be 2. So after reading the data, after the read and write disk reads data from here, it directly goes to sector 2 and starts reading it from there. So instead of having consecutive memory allocations, it is better to apply consequential processing, or sorry, interleaving method to actually get the data. So I hope the video has been useful to you, and let me show you the complete view so that you can understand everything. This is the spindle. This is the spindle on which the discs are rotated. Actually, as I told you, there would be 3 discs, a minimal of 3 discs, but here I have shown with the 2 discs. This is the read and write head, the white portion. This is the read and write head. This is the actuator arm, and there would be something called an actuator from which the CPU sends the signal and actuator receives it. Well, this is it then. Have a look at the 3D graphics. Enjoy.